Welcome everyone to Inside Gyros. Again, inside home, 1 month and a half in quarantine here in Poland, but we're doing everything to fight this virus and make the things better. I hope you guys are also at home. And now that almost everyone is at home and the flying unfortunately is very low and just be at home is even better, we're going to take this opportunity to talk about gyros. And the idea of this video and the videos that I will start shooting from here, that I don't have a machine available, is to just talk about gyroplanes. So if you know a lot about gyroplanes, if you have seen my videos and so on, it will be a little bit boring. I'm just going to explain more or less what is a gyroplane. So this video is, or this series of videos are completely focused on the people who is at home, that is doing a lot of YouTube research, and they want to know about gyroplanes. So I'm going to start with the basics, with the real basic about the gyroplane. So let's talk about different points. The pre-flight on a gyroplane, the starting procedures of a gyroplane, the before/checklist that all pilots do, and then there's before takeoff, before taxi, before landing. We do something before an action, and the gyroplane takeoff. The gyroplane takeoff is, let's say, a unique characteristic of a gyroplane. Is where we divide from helicopters operation and airplane fixed wing operation. So let's talk about that in our very simple words, at home, inside gyros, inside home, about very basics on gyroplanes. Welcome back and thanks for watching. Alright, so again, because these videos are mainly for those who are right now at home, for you that is, you're at home and you're browsing the internet and you are interested in gyroplanes. So this is an introduction. This is when you sit down with me in an office and we're going to talk about gyroplanes, or you're going to sit down here in my living room and we're going to talk about gyroplanes. So I divide more or less the cool parts of the gyroplane and how I approach those moments, those events on aviation. So let's just start with the pre-flight. What's a pre-flight? Why pilots are, doing around, we have different names for the pre-flight. This is like the 360, walk around, pre-flight, inspection, name it that it is. I used to ride back horses. I used to jump in horses long time ago. And before, when you arrive to meet the horse, you start like checking the horse, you clean it, you see the chair, you see all the reins and all the things that you put in I don't know the name in English, all the things that you put in the nose and in the head. This is the moment, this is the preparation moment, and I always approach it kind of a religious ritual. It's a ritual for the pilots. It's a moment you take it by yourself, you remove distractions, and you just walk around your aircraft. You make the inspection. You feel the surfaces. You open the cockpit. You check that everything is off, that all the conditions are fine. There is no bird or something inside. Something fell down. It's a ritual. It's a moment when you have a number of items. There is always in a checklist, the pattern, the procedure. There is always a checklist. So you just go point by point. But when you do it point by point, you can also create your own routines. So what we do in a gyroplane, in an AG915, for example, we just check that everything is off, that the power is down, that the selector valve for the fuel is on. There is a bulb in the behind of a pilot that shut down the fuel in case of emergency. You just make sure that is on, is on. And then you walk around and you start from the left part of the aircraft to the back and you walk around. There is some videos that I have done. You can check in the channel the other videos about the pre-flight. But let's talk about the essence. when we are inspecting the aircraft, it's very important to remove distractions, not lose the loop. Sometimes when you're doing the pre-flight, and it happens a lot in gyroplanes when you are in a different airfield or when you open the airfield, gyroplanes call attention, regardless of what model. Gyroplanes are very cool, are nice machines. And sometimes a little bit show-off machines. Where you arrive, everybody will, all the attention will go to you. Everybody knows about the fixed wings, helicopters are everywhere, but gyroplanes are few. They're weird, they're exclusive. So sometimes when you're doing the pre-flight, somebody arrives and start asking questions. Or you have the friend who is driving around and ask you for some questions. So I always try to not get distracted in that moment. Because when you are losing the loop of the pattern, of the sequence of checks and all the parts that you have to check, if you lose that, you may skip one of the points. So this is a ritual. This is something you should take very serious. It's a very personal moment when you prepare. As I said, with the example of a horse, you have to prepare, you have to feel where is your mood, you check your weather, you check everything. It's a very nice prelude. It's the moment before you're gonna start up the engine. So if you have the chance in the near future, as soon as we pass all of this and we can go out of quarantine, find someone with a gyroplane. Find some friend with an airplane. Or if you don't have access, there is many videos around. And just go and do pre-flights. Understand the machine. See the machine. Feeling, touching, cleaning the machine. I love to clean the machines. Actually, I found more things cleaning the machine than doing pre-flight sometimes. Because when a pre-flight becomes a routine, becomes automatic, you may skip some points. So the main answers at the end of the pre-flight is to remove the vacuum filling. All the things that you're checking inside, you cannot check when you're flying. If you're in the air and you feel the vacuum filling, again, I think I have done the same example. When you think that you left your keys or your wallet at home and you feel that something is missing, if you have that in the air, it's not a good sign. Because maybe you lose something, maybe you forgot something, or you can just ruin the moment. You're not enjoying your machine. The machine should be for having fun. So you will check everything and you make sure that everything outside is attached. It's not going to fall, it's not going to blow away, it's not going to open, that all the components and all the control system, that everything is fine. So that's because it's so cool and so important to see these kind of parts and these kind of moving things that in some other models are hidden. So this is very important. This is very cool to have. So do your your pre-flight, take it as a ritual, make your personal moment. Some people do it with some music or something just to focus completely with the pre-flight. And again, avoid the vacuum filling in the air, just making sure you do a really nice pre-flight. So enjoy your pre-flights. When I was a child, I've been always fascinated with aviation. It's been the only thing that has been in my mind since I know that I'm alive, literally. Everything is about aviation, everything is about airplanes. And I was completely fascinating when you fly an airline, and I was able to look long time ago, you can actually, they fly with the open door in the cockpit, so I was always trying to watch what the pilots were doing. And before the takeoff and before the pushback and the taxi, I was fascinating with the guys just moving around like an octopus, clicking buttons and checking things, and that was fascinating. It's actually one of my first passions and love things and things that I remember about aviation when I was a child. Is that moment when they start clicking and doing things. So the starting procedures in every single aircraft in the world, they have a lot of things in common. First of all, is just to get in, close the doors, latch if you have to, like in Piper, that you latch, or in the Cessna, that have this kind of really old refrigerator close, like boom, there we go, something like that. So you just make sure you're enclosed, that it's not going to open, that the windows are closed. Or if it's really hot, you just open your windows. I know sometimes I taxi with the doors open when it's really hot. Yeah, we can do that. But, don't do this at home. I'm just trying not to say. I'm a CFI, so I try not to give bad example. But, we all do some stuff. So, before we start moving, we just sit down in the cockpit and we take our checklist. Again, the checklist is that, cheating list. The things we should not relate on memory. There is in aviation there is things you have to memorize. Is memory items in case there is memory items in case of an emergency or an abnormal position, abnormal situation. There is memory item things you have to memorize and react immediately to do. And limitations. There is the only two things under my concept and under my opinion that should be memorized. Should be like muscle memory, like in a weapon thing, like in an instruction thing, like military stuff. Memory items and limitations. Those are the two things that should be completely memory, muscle memory, immediately action. But the rest of the things are in manuals, are in papers, are in checklists. So, before we start, you make sure you take your checklist and you do a pre-flight. The gyroplane don't have many items. It's not an MD-80 or a 747-100. They have 300 items to start. It's not the space shuttle to have, thousands of components and things to check and etc. No, it's a simple thing. It's actually like 4 or 5 things that you have to do, but it's better to review. It's better to check the checklist, not to leave some things behind. Now with the 915 engine, with the Rotax 915 engine, there is a little bit more procedures. You have to turn on the electrical system. You have to turn on the pumps first. You have to check the pressure. So these are small variations that secure your flight. You make sure that you don't leave something behind when you start your engine. And it actually make it easier, the procedure, so you do, okay, we're going to do this and going to do that. And again, it's a really cool part of the flight. I approach it like when I'm tuning an instrument. When you tune an instrument, before you play in front of your friends, or if you play in front of an audience, or you're a musician or whatever, or just me, like I only do noise with a guitar and barely know how to hit the drums with compass. When you tune it, before you play something, so you start feeling, checking the tone, checking how you sit down, checking how you strap in, you get your instrument set. When you turn on the engine, you listen your engine, you check the parameters, you see that everything is fine, then you check your radios, you check your communication, you see if you're flying with an intercom, if the other guy can hear you, then you don't have to scream. You check your navigation, you light up all the systems. So again, this is a really cool part for those that we love aviation. This is a really cool moment when you start taking, all the systems start going alive. The aircraft is alive. It's alive. It's moving. Again, we go back to the horse, analogy. It's moving. It's not secure. Remember to put the parking brake. Now it's dangerous. Now it can bite you. So you have to be careful just to keep your brakes on, just to check your power, check everything, do not engage any rotation, just check your surroundings, prepare for the action, tune your instrument for the play, for the song. So the pre-flight, the before starting procedures, the after starting procedures, all these moments, you should understand it and take it with calm. Many people say that aviation is the fastest way of transportation for people with no hurry. You never approach, if you approach aviation with a hurry, and more if you're a sport pilot, you are doing it wrong, dude. That's not the way it is. Never in a hurry. Never in a hurry. And we're sport pilots. We're not in a hurry. We fly for fun. We don't have to take schedules, or we don't need to, run because operations need to go down, or you have the slot to take off or the pushback. No, we're lucky. We're not flying in that kind of pressure. We can take the aircraft out. We can take our time. We can clean it. Never, never, never do it in a hurry. Hurry will equal problems in many aspects of life. But in aviation, it's really, 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 important. Never take it in a hurry. So, again, prepare your instrument. Understand what you're going to do. Do your checklist. There's many checklists online. Again, if you have a friend who flies a gyroplane, when you're going to get a demo, to fly a gyroplane, wherever you want to go, just, sit down and read. I used to suggest to my students to do cabin time. The athletes, the Olympic athletes, and any athlete, that someone that performs any sport in some matter of discipline, they imagine, they do it. Sometimes, I don't know if you have seen those guys who do climbing or bouldering. I don't know the term exact. The climbing, when they do it in a competition, they actually you see the guys imagine how they're going to move and the angle and the knee, and they put this, and then they go here to the left, they move right. I'm pretty sure if you're passionate with the airplanes and aviation, if you have seen videos of aviation, you have seen the acrobatic pilots doing the movements and the maneuvers first in the head. Well, we can do that in our scale, in our small gyroplane sport pilot scale. If you're learning gyroplanes, and if you're in a flight school and you're in the process of understanding, take a time. Take a couple minutes, 10, 20 minutes. Sit down in the cockpit, inside of the hangar. Take your checklist and go and do. Teach your hand where are those switches. What are the actions to do? Cabin time. Give yourself time and teach your brain how to do it. It happened to all of us when we start flying. When I started flying, it was noise. It was pure noise. I was not understanding nothing. In theory, I was good. I passed my test. I passed my ground school. I thought I was an astronaut at that time, and I jumped inside the aircraft, and I have no idea what I was doing. It was only noise. Still, sometimes you don't understand what's going on. And to remove that noise, it takes time. It takes time when you get used to the noise, get used to the procedures, when you start doing it, naturally, fluently. So, to fix that, you can do the same like the athletes, the same like sport, the same like the acrobats, the acrobatic pilots, the same like military. In the military, when you have to get inside of a building or something, you do rehearsals, you train, repetition. That removes the noise in the moment you have to perform. So, it's a very nice moment now that many things are closed and you don't have, you can just go to the hangar or just download some checklists or understand, just print the cabin and, do the things in your mind. Just train your brain to do things. Believe me, there is a very good exercise. It's fun. We all love. If you love aviation, you will have fun and you will be more professional and you will feel, like me sometimes that I want to be an astronaut. So, I feel like very professional doing things and even talking loud. So, before starting procedures, another ritual, another cool thing to do and to train in these days that we're not flying much. Every action, every moment in any machine that flies require some attention. We divide the flight in sections, from the pre-flight to the before start, after start, before, taxi, before takeoff, takeoff checklist, after takeoff, and many points. Climb out, before descent. In the sports aviation, in the recreational aviation, we don't have that much. In the commercial aviation, they have before descent, climb out, landing. There are way more moments. But why we divide the moments? Because every time we want to change the attitude, the movement of the aircraft, something can happen. When you fly straight at level, and the amount of failures in straight at level are really few, because the aircraft is stable, everything is steady, so there is no many things that can fail. But as soon as you change something, when you remove the power, for example, temperatures change, things in the engine move, and if something is broken, this is the moment that something pop up. So that's because we have the before dash checklist, right? So understand your moments. Now that we are all grounded, or not all, but many of us were grounded, we can take this time to take a second and understand your moments. Understand if you're learning, if you want to start flying gyroplanes, there is a lot of information you can find, and if you get into the websites and the Gyropedia, for example, all these they give you amazing information. So you can take this information and create your own journal, your own diary, your own thing. So, okay, from this moment to this moment, I should do this. And then you practice like a crazy person in the living room. So your wife, they will understand that you're completely crazy. So you will go to your living room and start like doing it aloud. I mean, speaking loud, it works very good. It's call outs. Even if you're flying solo, I mean, it's good to do loud call-outs. It's actually a good exercise. Find your moments and understand your before taxi, before takeoff. Make sure that everything is ready. Not to go into the takeoff and, I forgot something, and then you have to reject. And remember, in aviation, every accident or every incident is a chain of actions before. So from the moment of the accident, let's say the moment of the accident or the incident, before that, it was some things that caused that thing, and then all the reactions after the moment that everything starts. So if you manage to block this moment when everything is going to that issue with checklist, preparation, understanding, making sure, being safe. If you're doubt, no go, just stay and be short. If you make blockades to this moment, you will not have the reactions of when you lose concentration, when everything goes wrong, when you have vibration, and then we are not really, I mean, there is a lot of the test pilots, we need to control ourselves. When something goes really bad or when everything is wrong, you continue. You just continue. But you train yourself to have that level of confidence that, okay, I can continue, I need to lower, I need speed or whatever. But not everyone is a test pilot. Not everyone have enough hours. And even if you have thousands of hours, sometimes you get nervous. If something goes wrong, you lost your loop, you lost your concentration. So the before something checklist help you a lot to do that. So write down, now that you have time, now that we are all at home, write down checklist. Write it down by yourself. Understand. So why I do that? Why I should turn on the lights, for example? Why we put the lights on before we taxi? That's something that, I mean, if it's day, it's sunny, why we do that? Well, because if someone, the shape of an aircraft, on a gyroplane, for example, when you see it by far, in the horizon, sometimes you cannot see it because it gets camouflaged from the background. So when you put the light on, that changes something. So there is an aircraft. The beacon, for example, we don't have beacon. We don't have beacon, but before you start the engine, you should turn on the beacon. It is the red light that is start like moving around. In the big aircraft, in the airliners, is in the belly. So of course the people in the ground, when they see the red thing is moving, okay, need to get out of here, otherwise we're gonna, they're going to turn on the engines and it can damage the engine with a head on an arm. And the engines are very, very expensive. So these small things, understand every point. Why you do it? That's help you a lot. Because sometimes when you start training, they give you the information and they say, okay, this is the checklist, and you start like a robot. Master switch on, selector on, pumps on, battery on. Why you doing that? Just stop a second. Why you're doing every action? This is the right moment to take the manual, to take the SOP, and understand why you do that. What happens if you don't do it? So, and teaching yourself, explaining, like if you're teaching someone, that helps a lot. I think that's one of the reasons that I like to teach, because I'm learning a lot. Every time I teach, I learn more things. And when you prepare a session, and when you prepare, you're like, I didn't know that. I used to do it, and I didn't know why. But if your student asks you why you do that, it's like, very good question. Why do we do that? Well, I don't know. We used to do it in the flight school, and I just keep the tradition. No, there is always a reason for doing things. So take this time to just, sit down, take all your notes, take all your, checklists, and understand why you do these actions and what happens if you don't do it. Simulate it in your head. So that will help you a lot. That will give you some discipline in the air. So the before something checklist, review. You don't have to memorize, but it's better to know by heart what happened when you do it and what happened if you don't do it. So, to finish, and not to bore you more, I'm just trying to be as short as I can. I know we have time. I know if you're watching this in your pajamas at your studio, just browsing about gyroplanes. Thanks for watching. Thanks for watching all the videos. There is some videos flying. There will be more videos flying soon. No worries. For now, we're just, regrouping here, and we cannot just do much. But there will be very nice videos flying coming soon as everything happens. There is some surprises coming on. So, but I want to talk to you something. What is the difference? What is the unique characteristic of a gyroplane? Is the takeoff. Gyroplanes look like helicopters. They fly more or less like a fixed wing, but they have something special, and it's the only thing that is very different from helicopters and is very different from fixed wing, and is the takeoff, the procedure inside. Is what we pilots, I start as a fixed wing pilot, and the helicopter pilots have the issues, is that moment when you have to do something that is completely different, either in a fixed wing or in a helicopter, on a rotor wing. The takeoff. The takeoff is it's very interesting what is happening, because we pre-rotate. Some people, what is the pre-rotation? So the pre-rotation is to just take the rotor that is steady. We engage a Bendix, and it's a Bendix actually the same Bendix for the cars to start a car. So we have a truck Bendix to start a car. It's the same thing. It's a small gear that goes out, clump like this, engage to a gear in the rotor, engage, and start doing the first spin. Is spinning, giving the first push. And it's actually from a car. I mean, many of the models, and we don't design something just for gyroplanes. We use a truck one, and it's clank, it engage. It's very tough, it's very strong. So we engage, we use the flexible shaft, and in the back there is a clutch that they have some belts, and it's using the spin of the propeller in the engine. So they start moving a flexible shaft, clump, it goes up and starts spinning. This is how it works. It's very simple. It's not rocket science or something secret that we gyroplane manufacturers don't want to tell. No, it's actually a car Bendix. So we start spinning, and what we want to do is make a saucer, is make a frisbee. The rotor on a gyroplane, it have a fixed pitch. It's a very, very minor pitch. Helicopters, to go up, they put more pitch, and they put less pitch when they go down with the collective. So this is the difference. This is one of the main differences. So when you go up, you just put the collective up, full power, collective up. countermeasure with the pedal and a little bit of the, well, it's more complicated than it looks, but it's what it is. And you put all the pitch and you start going up. The gyroplane don't have that. What we do is we have a flat wing. We have the NACA, we have the profile. It's a subsonic profile. And I will, forward I will tell you a little bit more about why it's so important to keep some speeds in a subsonic profile. It's not a supersonic profile. So we start spinning to make the saucer, to make the frisbee. When you go to a certain RPMs, you get a frisbee, you get a saucer, right? And it's teetering, it's doing like this, so to create lift. So the blade that is going forward, if we're going in that direction, the blade that is going forward goes up, and the one that is coming back goes down. That's because we have the teetering, and in the air it's doing like this. It's doing something like this. The teeter ball is here, and the rotor is doing this. This is what it's doing. So this is the difference between the lift. The symmetry of lift. This is a very weird thing and very mathematical thing that we use to show off with the girls. Oh, we use the symmetry of lift of auto rotation for flying. So this is what we have, and it's not science. Actually, it's because one is going up and the other one is going down. There is a different equation, but they both have the same results in 3 different points. So this is what it's doing. And actually, this teetering movement, this movement, the teeter ball, that is the ball that holds the whole, the rotor, is mounted on bushings, right? So in these bushings are just, they make some friction on the cube. And all this small friction and all these small movements, they transmit, and that's because we have the feedback, the small feedback on not the big one. If you have a really big one, let's put it this way. If you're flying and you hold the control, right? And the shake, move your hand, that's not good. You have to check your rotor balance, alignment, tracking, etc. But if you remove it and there is some remaining of the frequency, and if you hold it and there is no more move, you're good. You're good. So this is what we're doing. We're spinning. We're making a saucer. As soon as you make the saucer, that is more or less 300 RPM. 200 RPM. There is some things about the pre-rotation between the 300 and the 200 RPM. So some manufacturers said that if you have a pre-rotation of 300, you have a really short takeoff. Yes and no. I'm going to tell you something that is my opinion, is my point of view. Maybe I'm wrong. I know how to fly, but I'm not an engineer. And physics, so. If you have 300 RPM in your saucer, so that means the amount of surface in the area is bigger than if you have less RPMs. Less RPMs, more holes. Let's put it this way. The air will go, there is more holes around. If you have 300 RPMs and you go full back, you have more drag. So then it will be more difficult to start pushing. If you have a lot of, maybe I'm wrong. If you want to argue, it will be interesting to argue about this. You can send me an email, or in the PRA when I post this video in Facebook, you can do the comments. If you have 300 RPM and a lot of wind, and you go full, you may have the backward effect. The same thing with the gyro for the gyro pilots. When you land and you just keep it back, and with no power, you can go back. That's the same thing. You're just actually pushing back. There's a lot of surface pushing back. So for the AG915, for example, that we pre-rotate before the takeoff to 200. 200 is kind of the balance. It gives you a small balance between enough RPMs to maintain the dissymmetry and to not do the flapping, and to make it faster enough so that the wave became stable, right? But it's not enough. It's not too much to let the aircraft go faster. So you have faster motion forward, and then you go in the air. Maybe if you pre-rotate to 300, you should not go full back. Maybe you should keep it a little bit, flat and go. But don't do it. Don't. I'm just guessing. I'm literally guessing. I haven't tried. I would love to try. I think in this year when we meet and when we do some tour, I will try to fly another machines to have the 300 RPM pre-rotation before the takeoff, and I would like to feel if instead of going full pack, you just put it a little bit, just increase the angle and go. Maybe they will help. I don't know. That is even dangerous. If you don't have more than 300, you should not do that, because you may have some issues as soon as you pull. So, saucer, as soon as you start pushing, the RPMs will increase. 300 or above, you're in the air. When I say 300, it's in the rotors that they are between 8.6 and 8.8 meters radius. So 300, you fly between 300 and 400 RPM normally. 300, something below 300, you will have too much bumping. Something above 400, 420, the end of the rotor. So remember, you're taking this measure from the inside. As soon as you go out, the speed increase, right? If you are 400 and something inside of the ring, outside, the speed at the end of the blade is close to a supersonic speed. And this is when the subsonic shape that we have is very important, because if you start putting supersonic speed at the end, you will have sonic booms. Boom, boom, boom. The flapping, the pop, 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 pop. You can actually feel it when you do like maneuvers, like acrobatic maneuvers, and you just push a lot of G's, and then just spin a lot with pushing down. You feel like pop, 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 pop. The flapping, that's not good. That's not really good. Gyroplanes have limitations on speed, and if you start going really fast, is actually not good to encourage people to go fast. We have engines that go faster right now and that can take you faster, but it's not very responsible to tell people just to go faster. And then, no, that's not really responsible, because if you have a downdraft, an updraft, or some change, or you speed up with some G's, at the end it became supersonic. And if you know aviation, and if you get your ground training and you understand aerodynamics, the shape foil, when it goes supersonic, it's not going to work really well. So you don't want that at the end of your rotor, and remember, you're holding on that. So the kite principle that I always use, this is what it is. The gravity, the weight of the aircraft is keeping spinning when you reduce the speed. That's because we don't have stall, so we start going down. But you're flying with an umbrella. That's the only thing that is holding you. So if you don't take care of your umbrella, if you don't take care of what is happening there, just keep it in your limitations, you will always have a really nice flight. So remember, the frisbee, the kite, the umbrella, the principles. There is many videos about talking like that when I fly in. I encourage you right now to go to Wikipedia, to go to Gyropedia. There is the rotorcraft manual, the FAA, you can download it. The last chapter is about gyroplanes. It's very interesting, and it's all the questions from the FAA, they're from there. It's a little bit, not dated, but it's fine. I give you a lot of information. But go check that, check your manuals, take your time, regroup, understand, write down some things, why you do this, what happens if you don't do it, be safe, study more, and again, thanks for watching. I will try to take an SOP in the next videos and just, describe what we do with the SOPs and the limitations of the aircraft, what is the limitation, what we can do. There is another really cool things about the flying under the curve, why we cannot fly low and slow. I would like to explain it in very simple words. But anyway, if you want more information about training, sales, and everything, give us an email, give me a call. It's toll free. It's right there. The phone number and my email is going to be somewhere around here. Ask me questions right now. We're a little bit busy. We're sending another machine to the United States. But I'm here. I'm going to be in front of the computer most of the time. So I'm flying a desk for now. More surprises coming. Check our website. And again, thanks for watching. I hope you enjoyed this living room / hangar talk of Inside Gyros, Inside Home in the quarantine. Thank you guys for watching. See you next time. Bye.